Okay, in this video, we are going to be going through numbers 13 through 24, the second half of the multiple choice questions from the January 2023 Geometry Regents exam. All right, number 13, the equation of a line is 3x minus 5y equals 8. All lines perpendicular to this line must have a slope of. So key word here is perpendicular. The slopes of perpendicular lines are negative reciprocals to one another. But I need to first figure out what the slope of this line is. So we need to get this in y equals format. So I'm going to start by moving the 3x to the other side. And then I am going to divide both sides by -5. When I do that, I have y equals 3 over 5x minus 8 over 5. And when I take a look at this means my slope is 3 over 5. The negative reciprocal of that means change the sign. So let's make it negative and flip the fraction. That gives me -5 over 3, which is choice 4. All right, number 14, this is a key question. The Regents loves asking these questions where you must complete the square to write the equation of a circle in center radius form. So they give us an equation here, and here's how I want us to format it. We want all of the x terms first. Notice that's not the case. There's two x terms that are not next to each other. Then all of the y terms. And then we want the number, the term that does not have a variable, okay, the constant, to be on the other side of the equal sign. So I'm going to start by doing a little rearranging. And notice since I'm moving the 49 to the other side of the equal sign, I'm going to make that negative over there. After that, what I like to do is I like to rewrite this, and after the x's, leave a little space. After the y's, leave a little space. And we've learned in algebra that whatever you do on one side of an equation, you do to the other to keep it balanced. So I put 2 spaces on the left. I'm going to put 2 spaces on the right. To fill in those spaces, I need to look at these coefficients, the +2 and the -16. And in order to complete the square, I'm going to cut each of those numbers in half and square them. So when I cut 2 in half, I get 1. 1 squared is 1, and I write +1. Make sure you put a plus in there, not just a 1, but a +1. And let's balance it out, put it on the other side. When I look at the -16, cut that in half, I get -8. Square it, and I get +64, so I write +64. You're always going to get a positive value, just so you know. It will never be negative. So even though that was a -8, -8 squared, negative times a negative is a positive. All right, now look at the first 3 terms and factor. So I get x plus 1, x plus 1. Look at the next 3 terms. And let's factor y minus 8, y minus 8. And over on the right-hand side over here, I'm doing -49 plus 1 plus 64, and I get 16. Now we're almost done. Let's rewrite this. When you multiply something by itself, you're squaring it. And when I rewrite this with the squareds, you're going to see this is the equation of a circle in center radius form. So to find the center, take a look at these values and negate them. Take the opposite. So since that's +1, -8, I want the answer that has -1 and +8. So I know now that choice 1 is wrong, and I know that choice 3 is wrong. I need -1, +8. To get the radius, I take the square root of the number at the end. So 16, the square root of that is 4, and that gives me choice 2 as my answer. All right, number 15. These are called mean proportional problems, but I like to use little nicknames for them that are called hills and SAS, and I'll explain what that means. Let's label the picture first. So MG is 3, GL is 24, and we want to find the length of DG. So since I'm looking for DG, that's the altitude, I know that I'm going to use this SAS formula. So here's what it means. Hills is hypotenuse, and this all is in terms of the big triangle. So The hypotenuse of the big triangle is this. The legs of the big triangle are DM and DL, and the segments are the two pieces that make up the hypotenuse. In this case, since I'm looking for SAS, and I'm using SAS here, that formula is segment over altitude, I'm just going to abbreviate there, equals altitude over segment. And we're going to use the two different segments there. So the two segments are 3 and 24. The altitude I do not know, so I'm going to put x there. And now I can cross multiply. So x times x is x squared. 24 times 3 is 72. Square root, and I get choice 4. So just to give you a little bit more of an overview, I'm just going to redraw a picture here just so you could better understand. And you'll see this in some of my other videos too. Let's assume I'm drawing all of this accurately. The hypotenuse would be in reference to the big right triangle. There are 3 right triangles here. I'm talking about the largest one. The legs of that big right triangle are these. This is my altitude, and this is my segment. So if this problem had asked us for, let's say, DM or DL, those are the legs, so I would have used hills. So the two formulas are hills, hypotenuse over leg equals leg over segment, or SAS, segment over altitude, altitude over segment. If you do not know these shortcuts, there are still ways to answer this question. You could separate all of these triangles and find the corresponding sides and set up proportions. That will totally work here, but this is a nice shortcut in order to avoid doing that. All right, number 16, segment AB is the perpendicular bisector of CD at point M. Which statement is always true? We have to draw a picture here in order to answer this question. When you're drawing a picture on the Regents for something like this, don't worry about it being drawn to scale and making measurements a certain way, but just make sure that you're fitting the description. So it tells me that I have segment AB. Okay, so I know that I have to draw a line segment and that it's called AB. It is the bisector of segment CD. Okay, so I know that these two line segments, and I'm going to shift that over just slightly, make it look a little better. AB is the perpendicular bisector of CD at point M. So here's what that means. That means that CD has been, or that it forms right angles with AB. That's what perpendicular means. And it also means that CD has been cut in half since it was bisected. Now it wants to know what statement is always true. So it first tells me CB and DB. So I'm thinking, okay, maybe they want us to connect these here to form these segments. And I only know to do that because of what the answer choices say. So I'm going to go in and draw on all 4. All right, choice 1, CB is congruent to DB. So that one looks good. They actually do look congruent in my picture, but let's see if we can do process of elimination on the others. CD is congruent to AB. That might be the case, but I don't have enough reason to back that up, so I'm going to cross off choice 2. Choice 3 and 4 are talking about similar triangles. So triangle ACD is similar to triangle BCD. In order to get similar triangles, I need to know that I have 2 pairs of corresponding congruent angles, and I don't see that here, so I'm going to cross that out. And choice 4 says triangle ACM is similar to triangle BCM. Well, each of those 2 triangles, I have 1 angle marked off in each, but that's not really enough information here, so I'm going to also cross off choice 4. So let's go back to choice 1, which looks right based on the picture. And let's see if we could find a little more verification as to why CB and DB would be congruent to one another. So I'm going to actually draw, I'm just going to slide here for a second. I'm going to draw just the right-hand side of this picture. So here's C, B, D, and M. We know these are right angles. we know that CM and MD are congruent. When I look at this picture now, I can see that there are two triangles that are congruent to one another. And if you think to proofs, I know that MB is congruent to itself because of the reflexive property of congruence. And now these two triangles look like they are congruent by side angle side. Once you have congruent triangles, any of the corresponding parts are going to be congruent to one another. So CB is congruent to DB. Those are two corresponding parts. And now we have verified why choice 1 works. So remember, we don't necessarily know if we're drawing our picture to scale, but now we have actual geometric proof as to why choice 1 is correct. All right, number 17. In the diagram below of circle O, AC and BC are chords, and ACB is 70. If OA is 9, area of the shaded sector. So sector area, the formula is the central angle over 360 pi r squared. And I've been seeing the Regents do this a lot lately, where they do not give you the central angle, but they give you an inscribed angle instead. So here's what we do with that information. The inscribed angle ACB is 70. So that tells me that this arc is going to be 140 because an inscribed angle is always half the measure of its intercepted arc. A central angle is equal to the measure of the intercepted arc. And now I know my central angle is 140. So I have 140 over 360 pi, and the radius they told us was 9, so 9 squared. So let's put this in our calculator. When I do this, I'm going to stack my fractions so that I don't have to worry about parentheses. So I'm doing alpha y equals to do that. And I notice all of the answer choices are in terms of pi, right? See how there's pi in every answer choice? So don't put pi in the calculator. Just type everything else. So 9 squared, hit enter, and I get 31.5. So once I put pi back in, I get choice 4, 31.5 pi. Number 18, quadrilateral BEST has diagonals that intersect at D. Which statement would not be sufficient to prove quadrilateral BEST is a parallelogram? This is a tough question because we are not even given a picture to start off. So I'm going to just draw a four-sided shape. And when you're labeling it, it does matter a little bit how you label. So if you put B here, make sure E is in one of the two spots next to it, one of the consecutive angles. So E cannot go here. You can't jump across the shape. So I'm going to just put E in the top right corner, but you could have done bottom left as well. And I'm just going to go in a circular motion around. So the diagonals intersect at D, okay? And I drew mine kind of like a parallelogram. I don't know that to be the case. I'm just following the description. It's got to have four sides. It's got to have these diagonals. And it says, which statement is not sufficient to prove BEST is a parallelogram? All right, let's read these answer choices. 1, BD and SD are congruent. ED and TD are congruent. That's true about a parallelogram, that the diagonals bisect each other. So that tells me I have a parallelogram. Choice 2, BE is congruent to ST. And ES is congruent to TB. That's true in a parallelogram. The opposite sides are congruent. Choice 3. ES is congruent to TB. And BE is parallel to TS. So I'm going to put the parallel markings on those. Now, in a parallelogram, it is true that opposite sides are congruent, but it doesn't tell us about both pairs of opposite sides here. And it's true that opposite sides are parallel, but it doesn't tell us about both sides here. So I'm going to hold on to that information. And I'm going to look at choice 4. ES is parallel to BT. And BE is parallel to TS. Now they're telling me about both sets of parallel sides. So I know that that's true. So I believe that choice 3 is the answer. Now, based on my picture, that probably looks confusing. And that's because we drew the picture on our own. So I'm going to draw the picture a little bit different this time. Remember, it says that it's a quadrilateral. The sides are BEST. And we know that the diagonals are going to intersect one another. So I'm going to put, we could put BEST going around. I'm going to put the diagonals. And now reread choice 3. ES and TB are congruent. BE and TS are parallel. But look at my picture. So that looks true. All those facts look true, but I do not have a parallelogram. I actually have an isosceles trapezoid here. So since I can come up with a counter example, that's why it's going to be choice 3. Okay. That's probably, in my opinion, one of the toughest questions on all of the multiple choice on this exam. All right, number 19, the equation of line T is 3x minus y equals 6. M is the image after a dilation of 1/2 centered at the origin. What is the equation of line M? I don't like when the equations are not in y equals form, so that's the first thing I'm going to do is get y by itself. And I'm going to divide everything by -1. Okay, once you have it in y equals form, look at whatever the center is, in this case the origin, and see if that point is on this line. Is the point 0, 0 on the line 3x minus 6? You might be able to say no automatically because we can tell the y-intercept is -6 and not 0. But let's verify. Does 0 equal -6? Nope, so that's not true. So I say here that the center is off the line and that it's the origin. Anytime that happens, you're going to keep the slope the same, but multiply the y-intercept by the scale factor. So the slope, keep it 3, means choice 1 and 2 are automatically wrong. And we're going to multiply the y-intercept by the scale factor. So the y-intercept was -6. Multiply it by, I'll do this in different colors so you can see. Multiply it by the scale factor of 1/2, and I get -3. And that gives me choice 4. Let's say, for instance, that we did get that the point was on the line. You would keep the entire equation the same. All right, number 20, a cylindrical pool has a diameter of 16, a height of 4. The pool is filled to 1/2 foot below the top. How much water does the pool contain? And we are given a conversion here that we'll deal with at the end. Anytime we see volume, you go to your reference sheet and copy that volume formula. The radius is 8. Notice they're giving us that little trick in there. The diameter is 16, so have that. And the height is not 4 because it's only filled 3.5 feet high. So I'm going to plug in 3.5 there. And let's just put this in our calculator. So I have pi, 8 squared, times 3.5. And so I know that the volume of the pool with all of the water is 703 point, and all of these decimals, we want to copy all of them. We only round our answer at the end of a question. I'm not at the end yet, so let's leave that. And you might say, well, wait, I am at the end. It's choice 1. Well, this unit right here is cubic feet. The problem is asking us about gallons, so I do have to do a conversion here. In order to convert this, I'm just going to put this all over 1. And I am going to multiply by that conversion rate. So I'm going to do 7.48 gallons over 1 cubic foot. So you might be like, why is the 7.48 in the numerator rather than the denominator? We need the cubic feet to cancel out. And that means we need them in diagonal location so that we could do that, right? Because if I multiply that out, I'd get cubic feet over cubic feet. And that cancels and gives us 1 or reduces to 1. So I'm going to multiply my answer by 7.48. And I get 5,263.8 to the nearest gallon. That's choice 3. All right, 21. The area of triangle TAP is 36. A second triangle is JOE is formed by connecting the midpoints. What's the area of triangle JOE? This question reminds me of just like a question that like you would learn when you are younger and you learn about fractions. So I'm going to draw a triangle TAP. No idea if I'm drawing it, what it actually looks like, but that's okay. And JOE is formed by connecting the midpoints. So let's connect those midpoints. So JOE. Do I know that J is the one between T and A? Nope. I'm just going to guess and put it in there. It says, what is the area of JOE in square centimeters? Let's think back to when you learned fractions as a kid. If I drew this up at the top, right, and I took that rectangle and assumed those parts are all equal there, you should be able to tell me that I shaded in 1/4 of that rectangle. Okay, again, assuming I divided that equally. Well, look at our picture here. Didn't I shade in 1/4 of the big triangle? So 1/4 of 36 gives me 9, which is choice 1. All right, number 22. On the set of axes below, AB has coordinates -3, 4 as A and 5, 2 as B. If it's dilated by a scale factor of 2 centered at 3, 5, so I see a point here that they're talking about that's not plotted, so I'm going to go in and just put that's the center. What are the coordinates of the endpoints of its image? I cannot just multiply the two coordinates by 2. Notice if I did, I would get choice 3. That's the trap answer. I can only do that if it's centered at the origin, which it's not here. So we often think about dilations as just multiplying by the scale factor, but really what you're doing is you are changing the distance from this fixed point or the center. And it's actually very easy to do, especially since they graphed A and B for us already. So on your picture, plot the center. And you notice from the center to, let's say, B first, how it's right 2 units, down 3. Okay, so let's make a note of that. Right 2, down 3. Now, let's double that. So let's make that right 4, down 6. So I'm going to go right 4, down 6, and that's where B prime is. So B prime, I can see, is 7, -1. At this point, there's only one answer choice that matches that, so I feel pretty good that the answer is going to be choice 4. If I wanted to verify that, though, sure, go and do the same thing with A. From the center, start at the center. Center's your starting point. From the center to A, I'm going left 6, down 1. So now repeat it. You could even just start from there and go left 6, down 1. Okay, you can make it almost look like a little staircase there like I did. And what's that point? -9, 3, and I can see choice 4 is correct. Okay, let's take a look at number 23. In the circle below, AD, AC, BC, and DC are chords. Line EDF is tangent to the circle at D, and AD is parallel to BC. So I'm going to mark off AD and BC as parallel. I'm going to guess that that's going to be a key part to this question because the beginning pieces are just describing or naming the segment, saying this is a chord, this is a tangent. But AD being parallel to BC is giving us an actual fact that we can work with. So one thing that is always good to look for when you have parallel lines is there some sort of angle relationship you can identify in the picture? So, for instance, there are corresponding angles, alternate interior, alternate exterior, same side interior. Those are angle relationships that are often formed by parallel lines. So I actually can see in this question, this is always a good thing to look for in proofs too, this Z shape. Okay, so anytime you can see this Z shape, and it could be a backward Z or sideways one, and they're formed by parallel lines. That's key. You need to know the lines are parallel. The angles within there are going to be congruent to one another. Okay. So I know that those two angles are going to be congruent. The angles in the corner of that Z shape. And I'm going to guess that's a key element to this question. So I'm going to leave those markings right now. Okay, and now let's look at the answer choices. Number 1, angle ADE. So ADE is this angle here, is congruent to CAD. And if I take a look at that, I do not see a reason why those angles must be congruent. So I'm going to bypass that one and try choice 2. 2 says angle CDF, okay, so this angle in here, is congruent to angle ACB. Okay, so let's take a look at that. So that would also mean that it's congruent to angle DAC, and this one I actually can verify. So I believe the answer here is going to be choice 2. Let's talk about how I know that. So I'm going to go in and erase my highlighting. And let's look at the first angle they gave me. CDF is this angle that's formed. I'm going to go back in with my highlighter a little thinner here. So CDF is this angle that's formed by the chord and the tangent. And anytime that happens, that angle is going to be half the measure of this intercepted arc, half of CD. Now let's look at the other angle, angle ACB. That's an angle that's formed by 2 chords, and it's an inscribed angle, and that's also half of the arc. So do we know that arc AB and arc DC are in fact congruent? And we do know that because AD and BC are parallel, those alternate interior angles are going to be congruent, which will make those arcs congruent. Let's clear that up a little bit better here though. So I'm going to actually take this question and I'm going to modify it. So I'm going to erase lots of highlighting here. Sorry about that. And let's look at choice 2. If they're saying CDF is congruent to ACB, we should agree based on that Z shape from before that that means CDF must be congruent to CAD, right? Because we already know these 2 angles are congruent to one another. Now let's look at those 2 angles. So CDF, I'm going to put my highlighting back in. Notice the arc it's intercepting. Okay, I'm going to go in with a different color here. And then CAD. Notice how it's intercepting that same exact arc. So therefore, those 2 angles are going to be congruent. All right, and for our last problem, in the diagram below of triangle ABC, D and E are midpoints of AB, so I'm going to mark those off, and AC respectively. DE is drawn. Which methods could be used to prove that ABC is similar to ADE? Okay, let's take a look at what we know here. So what I'm actually going to do, since we're talking about ABC and ADE, is I'm going to just draw these triangles separately off to the side. And we'll agree about a couple of things here. So AD and AB are going to be proportional to one another. And here's how we know that. Let's just make up numbers, right? I think that might make it easier here. Let's say that these sides are like 5 and 5. And let's say these are 7 and 7. Okay, I'm just totally making up the numbers. And let's say I transfer those numbers over to the question. So anytime you see a question and there's no numbers and you're like, oh, this is too abstract, put numbers in. Try it. And let's see if I can copy that over for the 7 and then the 14. You should now be able to see that the sides are, in fact, proportional to one another. 10 to 5 is a 2-to-1 ratio. 14 to 7 is a 2-to-1 ratio. Okay. I also see here that they both share angle A. So definitely right off the bat, I know that side angle side is going to work here. So side angle side in similar triangles doesn't mean the sides are congruent, but it means they're proportional to one another, which is definitely true. So I know choice 3 is good. That means choice 1 we're definitely going to eliminate here. Okay. All right, based on that, now I have to determine can AA or SSS work. And the key to that is knowing that if D and E are connecting midpoints, that this is something called a midsegment. So a mid-segment is going to be parallel to the third side, or the side that it's across from in the big triangle. So I know DE is parallel to BC. That means I'm going to get corresponding angles. And I'll use 2 marks for these just to keep it clear, and 3 for these. And you can see marking all over the place here, right? So definitely I have all my angles. I understand they're congruent. So choice 1 is going to work. I know, or Roman numeral 1 works. Choice 2 we're going to cross out now. And then let's talk about, can we prove side, side, side? Well, BC and DE, we do not have any measurements for them. However, if we have a mid-segment is always half the length of the parallel segment. So I know that it's going to be half of BC. So let's say, for instance, that I make up that BC is 20, DE is going to be 10, and now I see that all 3 sides are proportional to one another, and choice 4 will work. When you're taking the Regents, the multiple choice questions at the end definitely can be challenging. If we look at this one, very challenging. Anything to do with proofs is going to be tough. The one before that is very theoretical. You really have to know your circle rules. And then if I go back to, it was question 18 here. Again, that's another really challenging question. But keep in mind, you don't need to get every question right to still do well on the Regents. But a tip for these questions, 18, my best tip would be drawing pictures. Okay, I think these were the hardest questions. So 18, draw a picture. On 23, it would be looking for that Z shape, and that comes in handy with proofs too. And 24 would be my best tip, separate the triangles so that you're looking at 2 disconnected triangles rather than one picture. Okay, you can head to the next video in this playlist to see part 2, questions 25 through 31.